Welcome to Electronics Shikshalaya. So you are watching Digital Electronic Lecture Series. And today the topic of discussion is the RS flip flop using the NAND gates. Okay. So this RS flip flop can be used by using the NAND gates as the latch. Okay. So here we are using the NAND gates as the latch. Okay. So we know that latches are the basic building blocks of any flip flops. So in this section we will use the NAND gates as a latch. Okay. So let us begin our discussion. So the RS flip means there are two inputs, that is R and S of the inputs of the RS flip flop. So which are called the synchronous control inputs. So two inputs are called the synchronous control input because uh, the input affect the flip flop's output only on the triggering of the edge of the clock pulse. So why it is called synchronous? Because the means output change with respect to the clock signal. Okay, so whenever there is a edge of the clock, that the output will be changed. Okay, so that is why it is known as a synchronous control inputs. The inputs are synchronous control inputs. So as you know, the flip flops are the synchronous circuits. Okay, so output can change the state depending upon the clock signal. Okay, so that is why it is known as a synchronous flip flops. Okay, so the internal circuitry of the S triggered RS flip flop consists of three sections. So basically, this internal circuitry of this S triggered RS flip flop consisting of three sections. So let us see what are these sections. So you can see this is the logic diagram of this RS flip flop. Okay. So here we are using four NAND gates. Okay. There are four NAND gates. So G3 and G4. Okay. It is, you can see it is a, like the latch. Okay. So it is the internal circuitry of the RS flip flop. So this G3 and G4 form a latch. Okay. So because the flip flops are in building blocks of means flip flop we can construct by using the latches. Okay. So latches are the basic means building blocks from which the flip flops are constructed. So G3 and G4 consist means form a latch. Okay. This is the NAND based latch. Okay. Similarly, we have the G1 and G2. So these are called the steering circuits. Okay, so this steering logic circuit can be formed by using this NAND gate, that is G1 and G2. Okay, so actually this steering gates used to control the flow of data into the latch. Okay, depending upon the inputs conditions and the clock. Okay, so we have now the other section is a pulse transition detector, or there is a edge detector. Okay, so it will pass the means a narrow spike to this steering gates. Okay, so these are the three sections of any means flip flops. So we have any flip flops we can construct by using these three sections. Okay, so the basic NAND gate latch. Okay, so the basic NAND gate latch is formed by the NAND gates, that is the G3 and G4. So then G3 and G4 form the basic NAND gates. Okay, NAND gate latch. Okay. Similarly, the steering circuit formed by the NAND gates G1 and G2. So G1 and G2 form the steering circuits. Next, there is a edge detector circuit or the post transition detector circuit. Okay. So that is passed to the steering gates. Okay. So there is a clock signal. The clock is passed through the post transition detector. So it will have the narrow spike that will be passed to the means steering gates. Okay. The edge detector circuit generate a positive spike at the positive going or negative going edge of the clock pulse. Okay, so there will be this cross transition circuit. Depending upon the clock, it will generate this type of spike. Okay, so this is the positive spike. So the edge detector circuit will generate. Okay, if it either it may be positive going or negative going of the clock pulse, but it will generate a positive spike. This output of post transition detector, it will generate a positive spike. Okay, that will passes through this steering gates. Okay, the steering gates, that is the steer the you can see steering the direct or steer the narrow spike. So this is the narrow spike. It is going to either G3 and G1 and this spike. It passes through G3 and G4, that is the latch, depending upon this RNS inputs. Okay. Uh, So that is the internal circuitry of any flip flop. So in this case we are using the RS flip flop and we are using the NAND based latched. Okay. So this is the logic symbol of this RS flip flop. So you can see that this is the clock signal. Okay, this is the clock signal. It is the positive uh, edge of the clock. Okay, so the transition is from low to high. So this is the positive edge of the clock. Okay, that is why there is means this is a symbol of a clock. Okay, so this is the logic symbol of this RS flip flops. Okay, so next we will see how this RS flip flop work depending upon the inputs, different combinations of input. Okay, so let us see that. So we know that if logic 0 is any input of the NAND gate, it forces the output to be a logic 1. Okay, that we have seen in the latches. Okay, so in this case also the same formula or same concept is going to work. Okay, so we are doing first the R value is 0 and S value equal to 1. Okay, so this is our means logic diagram of this RS flip flop. So actually the clock is here clock equal to 1. Okay. So there is a clock. So we are assuming that there is a clock. Okay. In all our operations. So R value is 0 and S value equal to 1. Okay. So here we are applying R value equal to 0 and S value equal to 1. Okay. And this clock is equal to 1. Okay. The clock is 0 1. Okay. So what will the output now? So this G1 has the inputs 1 and both inputs is 1 and 1. Okay. So output will be 0. Okay. Similarly, this G2 have the one of the input is 1, another input is 0. So 1 0. What will the output? The output will be equal to 1. Okay. So next is if any input of the NAND gate is 0, it forces the output to be 1. So G3 has the one input of the NAND gate is 0. So it forces the output to be 1. So Q output equal to 1. Then this Q is connected to the one of the input of this G4. Okay. So 1 and 1, the input of this G4, the output will be 0. Okay. So in this case, you can see this is a set condition because this Q equal to 1. Okay. So when R equal to 0 and S equal to 1, the latch output is in the set state. Set means the Q equal to 1 and Q are equal to 0. Okay. So this is our first case. Let us see our second case when R equal to 1 and S equal to 0. Okay. So we are applying now R value equal to 1 and S value equal to 0. Okay. So clock is 1. Okay. The clock is 1. So this clock is there. So what is the output now? So G1 has the inputs is 1 and 0. So this output will be 1. Similarly, this G2 accepts the both inputs is 1 and 1. So, okay, the output equal to 0. So we know that if any input of the NAND gate is 0, it forces the output to be 1. Okay. So this output equal to 1. Then this GQ bar is connected to the one of the input of this G3. Okay. So 1 and 1, what will the output? The output will be 0. Okay. So you can see this Q equal to 0 and Q bar equal to 1. This condition is known as a reset condition. Okay. So when R equal to 1 and S equal to 0, the latch output is in the. So third case is the when the both inputs of this flip flop are 0 0. Okay. So let us see what happens. So we are assuming now. So Q value equal to 0 and Q bar value equal to 1. Okay. So the both the inputs of this means flip flops are 0 0. Okay. So S value is 0. We are applying S value is 0 and R value equal to 0. So here the clock equal to clock is present. So it is 1. Okay. So let us see. So now this G1 has the input 0 and 1. So what will the output? The output equal to 1. Okay. Similarly, G2 has the inputs that is the 1 and 0. So output equal to 1. Okay. Then actually we have to assume because we cannot predict this output that we have seen in the while we are discussing the latches also. Okay. So we cannot predict this output Q and Q complement. That is why you have to assume. Okay. So let us assume that Q equal to 0 and Q bar equal to 1. Okay. Then this Q is connected to the one of the input of G4 and Q bar is connected to the one of the input of G3. Okay. So the G3 received the input as 1 and 1. What will the output? Output equal to 0. Okay. Similarly, G4 has the input 0 and 1. So what will be the output? The output equal to 1. Okay. So we are getting the same thing what we have assumed. Okay. So let us check our second assumption. It is the Q equal to 1 and Q bar equal to 0. Okay. So in this case, Q equal to 1 and Q bar equal to 0, and both the inputs of this R and S are 0, 0. Okay. So the clock is there. Okay. So clock is equal to 1. Okay. This clock equal to 1. Okay. So now what will the output of G1? So G1 output equal to, so it will accept 1 and 0. So the output equal to 1. Similarly, G2 output equal to 1. Okay. So then we are assuming that Q equal to 1 and Q bar equal to 0. So this Q is connected to the this input of G4, and Q bar is connected to the input of this G3. Okay. So let us say that. So G3 has the input 1 and 0, output equal to 1. Similarly, G4 is the input at 1 and 1, the output equal to 0. Okay. So actually in both cases, it matches our initial assumptions. So that is why we can say it maintains the previous state, or we have the no change condition here. Okay. So when R equal to 0 and S equal to 0, the latch output is in the last state, or it is the no change condition. Okay. So let us get into our last case, that is the case number 4, when both the inputs are 1, 1. Okay. So we can see when both the inputs are 1 and 1. Okay. So this output equal to, what is the output? The clock is equal to 1. Okay. The clock is equal to 1. So output equal to, this output equal to 0. Similarly, the output equal to G2 output equal to 0. So 0, 0 means if any input of the NAND gate is 0, it forces the output to be 1. Okay. So both the outputs are, you can see, 1 and 1. So that is indeterminate state. So Q and Q bar should be complementary to each other. Okay. So this is the prohibited state or invalid state. So when both the inputs are 1, the latch output in the prohibited state. Okay. So let us see our truth table. So if clock is not there, so it is in the no change state. Okay. So if clock is not there, the latch output in the previous state, or latch into the last state. Okay. That is the no change state. Okay. Similarly, the when clock is there, so 0, 0 we have no change. And in order to set the latch, we have to apply R value equal to 0 and S value equal to 1. Okay. Similarly, in order to reset the latch, so you have to apply R value equal to 1 and S value equal to 0. Okay. So 1 and 1, the both inputs are 1, 1, then we have the indeterminate condition, or invalid condition. Okay. So this is the RS flip-flop using the NAND based latch. So we have seen how the RS flip-flop can be constructed using the NAND based latch, and then we have seen that how it operates with different combinations of inputs. Okay. So these slides are prepared using the two books. One of the book is from Anand Kumar. Second book is from P. Raja. Okay. So stay connected to this channel. Thank you for watching this video. Okay. So if you have any doubt, you can free to ask me in the comment section. Okay. So thank you all. So have a nice day.